We want to use the first derivative test to determine any relative extrema on the open interval from 0 to 2 pi of f of x equals 2 cosine x minus sine 2x. So the first step is to determine the possible locations of the relative extrema, which occur at the critical numbers. And the critical numbers are the values where the first derivative is equal to 0 or undefined. So the first thing we'll do here is find the derivative of the given function. So f prime of x is going to be equal to negative 2 sine x minus the derivative of sine 2x is going to be cosine 2x times 2. We do have to apply the chain rule here because we would have an inner function or u of 2x. Now this function is never undefined, so the next step is to determine when it's equal to 0. So now we'll set this equal to 0 and solve for x. There's a couple things going on here. Notice how we have two different trig functions and one's a double angle. So in order to write everything in terms of sine, we'll have to perform a substitution here for cosine 2x. We're going to replace cosine 2x with 1 minus sine squared x. So we'll have negative 2 sine x minus, we still have this extra factor of 2, so it'll be 2 times the quantity 1 minus 2 sine squared x equals 0. Now we'll go ahead and clear the parentheses and see if we can factor this. Notice when we distribute here, we're going to have a positive 4 sine squared x. Then we'll write the minus 2 sine x. And then here we'll have minus 2. Let's go ahead and factor out the greatest common factor of 2. And this does factor, we'll have 2 times 2 binomials equal to 0. So we'll have 2 sine x and sine x as the factors of 2 sine squared x. And then we want to put the factors of negative 1 in the second position so that the inner product and outer product is equal to negative sine x. So we'll put the minus 1 here and the plus 1 here. Notice how we have negative 2 sine x plus sine x does give us negative sine x. So the derivative is equal to 0 when 2 sine x plus 1 equals 0, and when sine x minus 1 equals 0. Solving this for sine x, we'll have sine x equals negative 1/2, and here we'll have sine x equals 1. So now we'll determine the angles on this interval where sine x equals negative 1/2 and where sine x equals 1. Let's take a look at our unit circle. So we're looking for a y-coordinate of negative 1/2 as well as a y-coordinate of positive 1. So here's a y-coordinate of positive 1 at pi over 2 radians, and we also have a y-coordinate of negative 1/2 here and here, so x equals 7 pi over 6 and 11 pi over 6 radians. So those are our three critical numbers. From this equation we had x equals 7 pi over 6 and 11 pi over 6. And from this equation here we had x equals pi over 2. So now we're going to take this given interval and divide it up into smaller intervals using these critical numbers. And I've already done that to save some time. Our first interval is from 0 to pi over 2. And then we have from pi over 2 to 7 pi over 6. Then from 7 pi over 6 to 11 pi over 6. And the last interval is from 11 pi over 6 to 2 pi. So now we're going to determine the sign of the first derivative in each of these intervals, and that'll tell us whether the function is increasing or decreasing in the interval, and then from that information we can determine any relative extrema. So let's see if we can determine a test value within each of these intervals. Some value between 0 and pi over 2, how about pi over 4? Some value between pi over 2 and 7 pi over 6. Well, this would be 3 pi over 6, so let's try 4 pi over 6, which would be 2 pi over 3. Some value between 7 pi over 6 and 11 pi over 6. How about 8 pi over 6 or 4 pi over 3? And this one's a little bit more challenging because after 11 pi over 6 would be 12 pi over 6, which is actually 2 pi. So this would be the same as 22 pi over 12. So let's try 23 pi over 12. So now we'll substitute these test values into the first derivative to determine the sign of the first derivative in each of these intervals. And to save some time, we're going to do this on the graphing calculator. So I've already typed in the original function into y1 and the derivative function into y2. So we'll determine the sine of y2 at these test values. So we'll do this from the home screen, but we do need to make sure that we're in radian mode, which we are. So let's go back to the home screen, and we're going to sub these values into y2. So we'll press vars, right arrow, enter, and then arrow down to y2, press enter. And now we'll type in pi over 4 in parentheses. Notice that it's negative, that's all we care about. And then we'll do the same for these three other test values. So vars, right arrow, enter, select y2, enter, and then we'll type in 2 pi over 3. Notice how it's still negative, and now we'll use x equals 4 pi over 3. It's positive, and we have one more. (23 pi over 12). So it's negative, negative, positive, negative. So this tells us the function is decreasing on this interval, still decreasing, increasing on this interval, and decreasing on this interval. So get an idea of what this means. Notice how on these first two intervals the function is decreasing, which means it's going downhill from left to right. But then at 7 pi over 6 it starts to increase, and then at 11 pi over 6 it starts to decrease again. So notice at 7 pi over 6 we have a low point or relative minimum, and at 11 pi over 6 we have a high point or relative maximum. Let's go ahead and record that information down here. Again, we have a relative minimum at 7 pi over 6, and we have a relative maximum at 11 pi over 6. So now that we know the locations of the relative extrema, we need to substitute these x values back into the original function to determine the relative max and min function values. And I've already set this up on the next slide to save some time. Here's our original function. We need to evaluate the function at 7 pi over 6 to determine the relative minimum, and then evaluate the same function at 11 pi over 6 to determine the relative maximum. So notice when I subbed in 7 pi over 6 for x, we had 7 pi over 6 here, and then 2 times 7 pi over 6 gave us 7 pi over 3. And then for 11 pi over 6, we had 11 pi over 6 here, and then 2 times 11 pi over 6 gave us 11 pi over 3. I've already determined these trig function values in green. You may want to verify them for yourself, but notice in its current form we have a common denominator of 2, and the numerator would be negative 2 square root 3 minus 1 square root 3, so we'd have negative 3 square root 3 all over 2. And this would be our relative min. And then the same thing here, I've already determined these trig function values here in green, which again you may want to verify. But in the current form we have a denominator of 2, we have 2 square root 3 plus 1 square root 3, so we have 3 square root 3 all over 2 for our relative max. Let's go ahead and record this on the previous screen. Again, our relative max was 3 square root 3 all over 2 at 11 pi over 6, and the relative min was negative 3 square root 3 over 2 at 7 pi over 6. Let's go ahead and verify it graphically. Notice on the left here we have a critical number that did not produce a relative max or min. That was x equals pi over 2. And then here we have a relative minimum at 7 pi over 6 and a relative maximum at 11 pi over 6. So I'm going to go ahead and stop here. I hope you found this example helpful.